Good day and welcome to the Math Salon. My name is Dr. Mende. For those of you who are new to the Math Salon, please feel at home. Welcome. The Math Salon is here for you to help you grow in your mathematical skills, to help you develop your mathematical skills. Today's video would be solutions to the quiz we had last Sunday. So the Math Salon gives every month a quiz to help you stay close to your study material and make you better prepared for your class and national examinations. The solutions that I give you are not unique. So there are many other ways you could have arrived at the answer, and that's the beauty of mathematics. Make sure you only follow the fundamental principles. I chose this version of the solutions as the ones that I think best trigger the skill that I expected from you during that quiz. It's important that because this is a video for the solutions only, that you also check the video for the quiz itself. Try the quiz yourself. Time yourself. It's supposed to be 1 hour. For students who already took the quiz, please make sure you have your answer sheet with you. After watching the video, you can correct them and know your score. This way, you're able to estimate what you knew before the quiz and what you know after the quiz. And if you do this for a few months, then you're going to notice your growth in mathematical skills with time. Okay, for the questions of today, the first question we had there was about remainder theorem. So you were told a of x is a polynomial. Usually when I solve this, I copy only the most important data from the quiz. So I don't write the whole question for time. So it means it's best if you watch the questions themselves before you follow this. So a of x is a polynomial with factor x minus a. When a of x is divided by x minus a, multiplied by x minus b, it leaves a remainder. And you are told the remainder is of this form. Find k if a is not equal to b. Yes, so that should be separate ones, right? So what was the idea here? You already learned in your polynomial and remainder theorem that if I have a of x, let's say it is divided by these two factors, then I can write it in the form x minus a, x minus b times another polynomial plus a remainder. In this case, this is a remainder will be a polynomial of order 1 if this is a quadratic one. But then you can always solve for that. You can then say, let this remainder be of the form ax plus b and try using the data you have to be able to get something that looks like that. But I made your life simple here because you should understand if I have something like 5 divided by 2, then this should be like 2 remainder 1. That means I can write 5 as 2 times 2 plus 1. That's the idea that we use here when we apply functions instead of numbers. So for this particular example, you're just supposed to say, okay, my a of x is divided by x minus a, x minus b, and the remainder is given in this form. So just write the remainder there, k of a minus x. If I try x equal to a as one of the factors that you see there, they say it's a factor, so the remainder is 0. Clearly, a minus a is 0, this will be 0, and a minus a is also be 0, which makes sense. So, what I should try then should be the b. This is the one that must have caused the remainder. So if I do that, then I get a b minus a, but b minus b is 0. Sorry, I missed q of x here. Plus that. So, but this term here will be 0. So what will remain is this. So this is 0 plus k into brackets a minus the b that we have there. What I'm left here to do is simply to solve for k. So to solve for k, then my k was equal to a of b divided by a minus b, and that was c. Question number 2. You are given a function f of t as the natural log of 4 plus x squared t. Find the gradient of the normal to the curve at t equal to 2, given that x is equal to 2. What was important for this question was for you to realize it is not every time that you see x that x is a variable of interest. In this case, it's my t that's the dependent variable. So the function describes something that you should do on t, not what you should do on x. X squared there, in this case, it's not our variable of interest. So if I'm differentiating, I don't have to differentiate with respect to x. It has to be with respect to t. You already learned that if you have f, a red marker, f of t equal to ln g of t, then f prime of t will be equal to 1 over g of t times the derivative of t. That's how we differentiate a log function. So if that's the case, we'll just apply the idea here. Since this is not my variable of interest and it is given as 2, I can already change it. I can actually say f of t is equal to ln 4 plus 4t, because this 2 squared. And then my f prime of t by the rule is 1 over what I see here, 4 plus 4t, times the derivative of this inside. This is a constant, so it goes to 0. This is only power 1, so it becomes 4. This 4 can actually cancel, and I get 1t. So this 4 cancels this and this. But we say this should be done at t equal to 2. So if t is equal to 2, then this one is going to give us 1 over 3, because that's 1 plus 2. This is a gradient of the tangent to the curve, not the gradient of the normal. But we know that the normal and the tangent are perpendicular at that point. And we know that the relationship between two perpendicular lines is that the product of their gradients is equal to -1. We already saw that before. So if that is the case, then we know that m1 times m2 should be equal to -1. So if I just say m2 will be equal to -1 over m1. Since I know the gradient of 1, I can look for the gradient of the number. I'll call it mn. That is -1 divided by the gradient of the tangent, mt. And that's -1 and 1/3, and that is -3. So the answer was D. You were told that the equation of the form Py is equal to Qx plus R, find P. The equation of the perpendicular bisector, so what was important, you have perpendicular and bisector, of a line joining these 2 points with the coordinates given there, is of this form: Py equal to Qx plus R, find P. So I will just assume that this is A and this is B. So if I have 2 points, the A and B, and this is a line joining the 2 points, a perpendicular bisector is one that divides into 2 equal parts and is perpendicular. So if I call that L1, then means what I'm required is look for the equation of the line L1 and express it in this form, and then I'll be able to see what is P. For me to be able to look for the equation of that line, I need to know the gradient of line and a point. At least that's the minimum. If you have 2 points, it's okay. Then you can easily write the equation of the line. But if you have only 1 point and a gradient, you can also still write it. You can use y minus y1 is equal to m into x minus x1 when you have only 1 point and a gradient. So if this is the case here, then what do I need? I need this point here, and I need the gradient of the line. But I know these 2 points, so I can look for the gradient of this line. And since it's perpendicular with this, I can also look for its own gradient using the property that we just saw above. So if that is true, then I will call this gradient AB, which is the gradient of the line AB. That is normally the change in y over change in x. So these are my coordinates here. Change in y, that is b minus 3b, that's 4b, divided by a minus 2a, that's minus a. Since this line is perpendicular to that, it means the gradient of L1 is equal to -1, the gradient of this one, that is a 4b on minus a. This inverts, the minuses go away, and I get a all over 4b. Since this is a bisector, it divides it into 2 equal parts. So this place can be my midpoint, M. So I'm going to look for the midpoint of AB. And the coordinates of midpoint are x1 plus x2 divided by 2, y1 plus y2 divided by 2. Those are the coordinates of the midpoint. So here my M, AB, will be equal to A plus 2A is 3A divided by 2, that's 3A on 2. B plus minus 3B is minus 2B divided by 2, is minus b. So for my line, I have the line going through this point, that, and with gradient, that. So I can just use this formula. So that is y here minus y1. This is the point that it goes through. So this is minus b becomes plus. My gradient m is given as that as a divided by 4b into bracket x minus the coordinate as 3a on 2. If you arrange this well, cross multiply 4b, I'll get 4by plus 4b squared is equal to ax minus 3a squared divided by 2. A times x, a that. I can multiply all through by 2, then I get 8. by is plus 8b squared is equal to 2a squared 2ax minus 3a squared. If we arrange this well, but this most important is the coefficient of this y. This can come this way. So your p was supposed to be 8b. And if you did that well, then the answer was E, because there was no answer there corresponding to that. For question number 4, the question was given in words that given two real numbers a and b, and given that the sum of their squares